All right. So remember last class we were talking about factoring the difference of two squares. So just as a quick review, just this one problem. If you had 49x squared minus 9, now at this point, you need to recognize very quickly how to factor this because it's not that difficult to factor. First of all, remember you need to look for the GCF. What's the GCF? 1. GCF is 1. Now, you have how many terms? 2. And you see that there's an x squared, right? So chances are you want to see if this is going to be the difference of two squares because the subtraction in the middle. So let's see if that's the difference of two squares. If this is the difference of two squares, then remember you can fill this part out and it looks just like this. And when we do the difference in sum of two cubes today, you're going to use that same idea that I just wrote here, except instead of it being the difference of two squares, we're going to look at the difference of two cubes and the sum of two cubes. So this is what you want to, in your mind, think right here. Now, this is 49x squared minus 9. So what's going to go inside that parentheses right here, that first parentheses? 7x, good. Because 7x times 7x is 49x squared. And then what's going to go inside that second? 3. And so notice, is this right here the difference of two squares? Yes. And so you can factor the difference of two squares. Remember the formula, and I'm going to use f squared minus l squared. When you have the difference of two squares, how do you factor that? Using f and l for right now. It'll be f minus l times what? F plus l. So if 7x is your first term and 3 is your last term, then how are you going to factor 49x squared minus 9? You're going to say f minus l, so what do you write? 7x minus 3 times 7x plus 3. There's your answer. Okay? All right, now let's kind of review something from a previous course. Okay, this is a review from a previous course. Suppose you want to multiply, and let's say I want to multiply number 1. Let's say we had 2x minus 3 times 3x plus, let's say, 5. And notice that one of the methods you learned to multiply these two binomials is to use what method? FOIL, okay. And so when I do that, I get 2x times 3x is 3x squared. And what's the outer? 10x. What's the inner? Negative 9x. And what's the last? Negative 15. So FOIL method, FOIL, first, outer, inner, last. When I combine like terms, I get 3x squared. What do I get when I combine the outer and the inner? X and then minus 15, right? And so notice that when I multiplied these two binomials out, I got this. Y'all agree? Yeah. Now, in a previous lesson, what you were asked to do, the last 2 or 3 lessons, what you were asked to do next was to factor this trinomial, 3x squared plus x minus 15. I'm sorry, 6x, you're right, thank you. So 6x squared. So when you're asked to factor 6x squared plus x minus 15, what were the two binomials you were supposed to write? Now that shouldn't be difficult, guys. I'm factoring this right here. What should be the answer? This right here, right? Those two binomials. So what should be this? 2x minus 3 times 3x plus 5. Now, the way that you learned this, though, was you either use trial and error or you use what method? The AC method. Okay? So, in the previous course, you multiplied these and got this. In this course, you're given this, and you're asked to factor, and you're going to give this back as the answer. That's what we've been discussing. Now, what if you had this? What if this would be number 3 is going to be multiplied. All right, what if in number 3 you're asked to multiply this? Let's say you had 2x minus 3 times x squared plus 5x minus 1. Let's say that's what you had. How'd you multiply that? First of all, can I use the FOIL method with this? No, the only time you can use the FOIL method is if you multiply a binomial times a binomial. This is not a binomial times a binomial. That's a binomial times a trinomial. Now, chances are you forgot how to do this, how to multiply a binomial times a trinomial. So I'm going to go back to number 1. I'll go back to number 1, and I'm going to multiply number 1 again. But instead of using a FOIL method, I'm going to use another method that you may have learned. And that's to use the distributive property. And so the distributive property, if I want to multiply this using the distributive property, basically that means this. You see this first binomial has 2 terms? 2 terms, right? So each of those terms is being multiplied by this second binomial. So basically you're saying this. You're saying 2x times 3x plus 5, and then minus 3 times 3x plus 5. So every term in here is being multiplied by the second binomial. Now I want you to notice something. What do you notice about these 2 terms right here? They have the same factor. So if I factor this out, don't I get this back? All right, so do you all agree that what I have right here is equivalent to this? Okay, now I'm going to go further with this. So I'm going to use the distributive property to get rid of the parentheses. What's 2x times 3x? What's 2x times 5? All right, over here, what's the negative 3 times 3x? Minus 9x. And what's the negative 3 times 5? Minus 15. Isn't this right here? This right here? Okay. And when I combine like terms, don't I get 6x squared plus x minus 15? So when I'm multiplying 2 binomials, I can use the FOIL method or I can use the distributive property. So when I go back to number 3, I can't use the FOIL method. So what's the only method I know I can use? Distributive property. So how many terms are inside that first parentheses? 2. So each of those terms are going to be multiplied by this trinomial. So you're going to say 2x times this trinomial, and then minus 3 times this trinomial. And just like I did this, the next step is to get rid of the parentheses. What's 2x times x squared? 2x cubed. What's 2x times 5x? And then what's 2x times a negative 1? Negative 2x. What's a negative 3 times x squared? A negative 3 times 5x. And then a negative 3 times a negative 1. Plus 3. Combining like terms, yes. Yes, you're right. Thank you. 10x squared right here, right? Okay, so 10x squared. Combining like terms, I get 2x cubed. What's 10x squared and a negative 3x squared? 7x squared, right? What's a negative 2x and a negative 15x? Okay, good. And then plus 3. So notice when I multiplied this binomial times this trinomial, I ended up with a polynomial with how many terms? 4. Okay, 4 terms. All right, now let's look at this one. Listen carefully to this. What if I had number 5 and I multiplied and I want to multiply this out? So suppose suppose I had 2x minus 3, and then times 4x squared plus 6x plus 9. Let's suppose I had that instead. So write 2x minus 3 times 4x squared plus 6x plus 9. Okay? Can I use the FOIL method? No, I have to use the distributive property. So I'm going to say 2x times this trinomial minus 3 times that trinomial, right? Okay, so 2x times 4x squared plus 6x plus 9 minus 3 times 4x squared plus 6x plus 9. Okay? Using distributive property, what's 2x times 4x squared? 8x cubed. What's 2x times 6x? 12x squared. What's 2x times 9? 18x. What's the negative 3 times 4x squared? Negative 12x squared. What's the negative 3 times 6x? And what's the negative 3 times 9? Negative 27. Okay. All right, so that's where I'm at. Combining like terms, I get 8x squared, 8x cubed. The 12x squared and a negative 12x squared, those are opposites. So when I add them up, I get 0. The same thing for 18x and a negative 18x. Those are opposites. So when I add two terms that are opposite of each other, I get 0. So when I multiplied this binomial times this trinomial, I ended up with how many terms? 2. In this case, it is 8x cubed minus 27. Okay? Now notice in number 3, when I multiplied this binomial times this trinomial, I ended up with 4 terms, a polynomial with 4 terms. In number 4, when I multiplied this binomial times this trinomial, I ended up with a polynomial with 2 terms. Now there's a reason. There's a reason why here you have 2 terms. There's a reason why all these terms right here cancel out. Okay? And it has to do with the relationship between the terms of this binomial and the terms that's in the trinomial. There is a relationship. There is no relationship here. And you're going to see what relationship I'm talking about in a little while. But there's no relationship here, so when you multiply all that out, you're going to get a polynomial with 4 terms. All right, now I want you to notice something. When I did this and I said to factor, you noticed that this right here was the difference of 2 squares. When I look at this binomial right here, this is not the difference of 2 squares. For one thing, x is being raised to what power? The third. Secondly, there is no whole number times itself, that's 27. The same thing for 8. There is no whole number times itself, that's 8. So 8 and 27 are not perfect squares. But what do you notice about 8 and 27? They're perfect cubes. Perfect cubes. So let's remind ourselves what perfect cubes are. So perfect cubes, just like perfect squares, the smallest perfect square is 1, the smallest perfect cube is 1. Now remember, when we discussed the perfect squares, we did this. Listen carefully. We said 1 squared, 2 squared, 3 squared, and so on. So when I do the perfect cubes, I'm going to say 1 cube is what? 1. 2 cube is what? 2 times 2 times 2. 8. 3 cubed is 3 times 3 times 3. What's the next perfect cube? Not 18. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And then 4 cubed, 4 times 4 is 16. 16 times 4 is 64. And then the numbers get much bigger. And so just like with a perfect square, for example, your perfect square, one of your perfect squares, one of your perfect squares was 169. One of your perfect squares was 169. So that means that if I were to take the square root of 169, I would get a whole number back. What's the square root of 169? 13. So 13 squared is going to equal what? 169. So when I take the cube root of 8, what's the cube root of 8? 2. Not 2 cubed. Cube root of 8 is what? I'm saying this. Cube root of 8 is equal to what? 2. The cube root of 27 equals what? 3. The cube root of 64 equals what? 4. And so on. So again, when I did number 1 right here, when I asked you to factor, you recognized that this was going to be the difference of 2 squares. Now I need for you to recognize that this is going to be the difference of 2 cubes. The difference of 2 cubes. And so when I factor the difference of 2 squares, remember that's where we fill in the parentheses, right? When you deal with the difference of 2 cubes and also the sum of 2 cubes, you want to do this right here. You want to fill in those parentheses. So basically, in your mind, and actually you really should write it out. When you write it out, you're going to say, all right, this is going to be the difference of 2 cubes if I can rewrite this as something cubed minus something cubed. And so what times itself 3 times is 8x cubed? 2x. 2x times 2x times 2x is 8x cubed. What times itself 3 times is 27? 3. 3 times 3 times 3 is 27. So this right here is the difference of 2 cubes. Notice the difference of 2 cubes. Now, I want you to also think of this way. So a while ago, remember how we said right here when we looked at the difference of 2 squares that 7x, I was going to think of this as my first term, f, and then 3, I was going to think of this as my last term. Same thing here. 2x, I'm going to think of this as my first term, and then 3 will be my last term. Okay? Now, let's go back and talk about this relationship right here. Whenever you factor the difference of 2 cubes, when you factor the difference of 2 cubes, you're going to get a binomial. See, this is a binomial, right? Times a what? Trinomial. When you factor the difference of 2 cubes, you're going to get a binomial times a trinomial. When you factor the difference of 2 squares, you get a binomial times a binomial. When you factor the difference of 2 cubes, you get a binomial times a trinomial. Now, you see when I rewrote 8x cubed minus 27 and I wrote it as 2x cubed minus 3 cubed? If I cover up those cubes right here, what expression do you see right here? 2x minus 3. What's my binomial right here? 2x minus 3. So whenever you have the difference of 2 cubes, that f and L will be that first parentheses, will be your binomial. Okay? Now let's talk about this relationship for the trinomial though. All right, now here's the relationship. Okay, listen carefully. So if I'm factoring the difference of 2 cubes, I'm going to write this as f cubed minus L cubed. If I'm factoring the difference of 2 cubes, Whenever you factor the difference of two cubes, you're going to factor it as a binomial times a what? Trinomial. Your binomial is the easy part. So if I'm factoring the difference of two cubes, f cubed minus l cubed, cover up the cubes, and what expression do you see? F minus L. That's your binomial. So it'll be F minus L. Now let's talk about the trinomial. The trinomial has how many terms? 3. So let's go back to number 4 right here. Now remember, my F here was 2x, right? Notice what I'm circling right here. I'm circling the first term of my trinomial. F was 2x. If I take 2x and multiply by itself, meaning 2x times 2x, what do I get? 4x squared. So to get this first term right here, whatever f is, you're going to square it. That's that first term. So to get the first term of your trinomial, you take f and you do what to it? Square it. Okay? So that's your first. Now let's talk about the middle term. All right, now look at this. My middle term here was 6x, right? Positive 6x, correct? Yes or no? All right. Now let's look at the first and the last. My first was what term? 2x. My last was what term? How can I get 6x from those two terms? Multiply. F times L. 2x times what? 3. But here's something else you got to remember, though. This is plus, right? What is this right here? Negative. So here's a relationship. So I know that this is going to have to be F times L, right? And I know that this has to be a plus. So the relationship is this. If your binomial, the middle sign is negative, then the second term here, the sign's going to be positive. Okay? All right, now notice my last term says plus 9, correct? All right, look at your last. What's my last term right here? What's L in this case? 3. To get a 9, I can say 3 times 3. Just like to get that 4x squared. To get that 4x squared, I said 2x times what? 2x. So meaning F times F. So here, that's going to be plus L what? Squared. So there's your formula. So the difference of two cubes will be F minus L, that's your binomial, times, and your trinomial is going to be F squared plus FL plus L squared. We're not going to go through this process to talk about the sum of two cubes, but this idea is the same. So let's talk about the sum of two cubes. So instead of saying F cubed minus L cubed, we're going to say F cubed plus L cubed. And guys, it's the process is the same. It's a binomial times a what? Trinomial. Just like with the difference of two cubes, if I cover the cubes, what expression do you see? F plus L. So that goes here. F plus L. See the relationship? So difference of two cubes, my binomial is F minus L. Sum of two cubes, my binomial is F plus L. Okay? The trinomial, almost everything's the same except for one thing. So the first term is still going to be F squared. The middle term is still going to be F times L. But here's the difference. See right here where I said when we looked at the difference of two cubes and my binomial was F minus L? Subtraction, you see a subtraction, right? So I drew this arrow right here. And I said for the middle term, you do the opposite sign. So if this is subtraction, this is going to be what? Addition. Over here, look what I'm pointing to. This is addition. This is going to have to be what? Subtraction. And then the last term is the same. So if you look at every term that's in both the difference of two cubes and the sum of two cubes, the position is the same for all of them. FF, LL, F squared, F times L, and L squared. The only difference between the two is this sign here and this sign here. That's the only difference. But everything else is the same.
In both cases, you do the opposite.
For the middle sign, yes. The middle term, yes. All right, so let's do some problems with that. And basically, I'll give you the formulas. You just need to know how to use them. Okay, you know how to use them. So let's look at number one. So number one, let's suppose you want to factor. You're going to factor number one. So let's go ahead and factor. Let's say we had all right. Well, I'm missing something. All right. Let's suppose we had this. Let's suppose we had x cubed minus 64. X cubed minus 64. What's the GCF? 1. How many terms do you see? 2. What sign's in the middle? Negative. All right, now you ask yourself, is this the difference of two squares, or could this be the difference of two cubes? What do you think? Difference of two cubes. So if you think this is the difference of two cubes, then here's what you need to do next. You need to actually write out, all right, if this is the difference of two cubes, then I can rewrite this as some expression cubed minus some expression cubed. What times itself 3 times is x cubed? X. What times itself 3 times is 64? 4. So this is the difference of two cubes, right? That's the difference of two cubes. So now I know what represents F. What represents F? X. And what represents L? 4. And now remember, to factor the difference of two cubes, it's a binomial times a trinomial. What's going to be my binomial? X minus 4. X minus 4. Now the trinomial, use your formula. So your formula says I take f and I square it. What's f in this case? X. So what's x times itself? X squared. Now, what's going to be that middle sign in this case? Plus. Good. Plus. Because this is subtraction. This has to be addition. And then the formula says I take the first and the last and multiply them together. So what's the first times the last? 4x. And then plus, and then this says I take L and I multiply by itself. What's L in this case? 4. What's 4 times 4? 16. So there's your answer. So you factored x cubed minus 64 as this binomial times this trinomial. So that's how you factored it.
So in the worksheet, you don't say factor, it's just gonna be the first part?
No, it's going to say factor.
Oh, okay.
So when you say the first part, you mean this?
I know, I meant like just that right there.
No. That's just your work.
Okay.
So if you're going to factor, and this is the difference of two cubes, then it's a very good idea to actually write this out. So you'll know first of all that this is the difference of two cubes, and then it also tells you what F and L are. All right, so that's your work, that's your answer. Okay? All right, number 2. Let's suppose in number 2 we had this. All right, suppose we had 27 plus 8x cubed. 27 plus 8x cubed. What's the GCF? 1. Y'all agree? Mm-hmm. All right. How many terms do you see? 2. So, now remember when we talked about the sum of two squares last class period, and I think on your worksheet, one of them is the sum of two squares that I gave you last class period. So, and I meant to review that earlier as well, but let me go back right here and just put this example. Suppose you were asked to factor, let's say 16x squared plus 9. What would that be if you asked to factor 16x squared plus 9? That would be prime because that's the sum of two squares. So that's the sum of two squares. And remember, the sum of two squares can't be factored, right? But you don't say that. You say what word instead? Prime. So when I look at number 2, though, number 2, that's an x cubed. So you want to see if that's going to be the sum of two what? Cubes. And the sum of two cubes can be factored. We saw that here, right? Okay, the sum of two cubes can be factored. So let's do the work. The work is this. That's where you say parentheses cube plus some expression cubed. This is the sum of two cubes if I can fill in those parentheses. What goes inside that first parentheses? 3. What goes inside that second parentheses? What times itself 3 times its 8x cubed? 2x.
So we need to flip that one.
No, leave it alone. No, you're fine. So if you're kind of referring to something like if you had negative 27 plus 8x cubed. Now in that case, I would rewrite it because the first term is negative. So I would just say 8x cubed minus 27, which in this case this would now be the difference of two cubes. So I would rewrite this. But that's fine the way it's written. Now if you want to rewrite it, she was asking, do we need to rewrite this? No, but if you want to, could you have rewritten this right here? It will be 8x cubed plus 27. All right, same idea. You use the same idea. What would be inside that first parentheses if you rewrote it? 2x. What would be inside the second? 3. You're in this case. What's f right here that I'm pointing to? 3. And what's L? 2x. If you did this one, what would be f? 2x. What would be L? It doesn't matter. It's still correct. All right, let's go back and do this one. So this is the sum of two cubes. So I found my f, I found my L. And so I know that when I factor the sum of two cubes, I'm going to get a binomial times a trinomial. What is the binomial? The binomial is always the easiest to fill out. 3 plus 2x. Good. The trinomial, if you go back to the formula, the trinomial says I take f and I multiply by itself. What's f in this case? No, what's f though? 3. So what's 3 times 3? 9. What is the middle sign? Minus. And then this says I take f and L and multiply them together. So what's 3 times 2x? 6x. And then this says it's going to be plus L squared. So L times L. What's L in this case? What's L? 2x. So you're saying what's 2x times 2x? 4x squared. So that's your answer. Okay? If I had done this one, what's your binomial? 2x plus 3. Times, now do y'all do know that these two binomials I'm pointing to are exactly the same, right? Because remember, addition is commutative. The order in which you add does not matter. 3 plus 2x is the same as 2x plus 3. But if I had put 2x plus 3 instead, then you'd say this for this first term of your trinomial, what's 2x times itself? 4x squared. Minus, what's 2x times 3? 6x, and then plus, what's 3 times 3? 9. Do y'all see that this right here is the same as this? Okay, so it did not matter which one you did. All right, number 3. Suppose in number 3 I had 64x cubed minus 27. 64x cubed minus 27. What's the GCF? GCF is 1. How many terms do you see? 2. So you need to ask yourself, first of all, am I going to ask, is this the difference of 2 squares? No, because for one thing, x is being raised to what power? The third. And secondly, 27 is not a perfect square. 64 is, but 27 is not, right? But you want to check and see if this is the difference of what? 2 cubes. 2 cubes. So the work, show the work. So here's your work. You're going to say something cubed minus something cubed, right? So what times itself 3 times is 64x cubed? 4x, good. What times itself 3 times is 27? 3. So I found my f. What does f represent? 4x. And what does L represent? 3. So when you factor the difference of 2 cubes, you're going to get a binomial times a trinomial. Your binomial is always the easiest. What's your binomial? 4x minus 3. Now let's talk about the trinomial. So to get the trinomial, remember your formula, you're going to take f and you're going to square it. So f times itself. What's f in this case? 4x. So think about this. What's 4x times 4x? 16x squared. Now remember, that's 4x minus 3, your binomial, right? So this is subtraction. So that means that this middle term is going to be what? Addition. F times L. What's 4x times 3? 12x. And then finally, plus L times itself. 3 times 3 is 9. So there's your answer. Huh? Yes, thank you. So 16x squared, right? Okay. All right, number 4. All right, suppose in number 4, I had this. I had 54x cubed minus 2. 54x cubed minus 2. All right. What's your GCF? GCF is what? 2, right? GCF is 2. So this become 2 times what binomial? 27 x cubed minus 1. Now, remember, you factor out the 2, but that doesn't mean that's your answer. You got to look at your parentheses, the polynomial that's inside the parentheses, which is 27 x cubed minus 1, and then you need to ask yourself, is this the difference of 2 cubes? It is. Good. Because I know, using the work, that what cubed is 27x cubed? 3 what? X. What cubed is 1? 1. So I found my F and I found my L. So 3x will be your F and then 1 will be your L. So now I know what my binomial is. What's the binomial? 3x minus 1. And now I can determine the trinomial. So the trinomial, the first term is where you take f and you multiply by itself. So it's 3x times 3x. 9x squared. Now remember, that's 3x minus 1. So the subtraction becomes addition. F times L, 3x. And then plus the last squared, the last times itself. 1 times 1 is 1. All right, now be careful. Don't say that's your answer because remember that here's a GCF. What's a GCF? 2. I should have said there's a GCF other than 1. The GCF is 2. So you gotta put that 2 in your answer. So it's 2 times 3x minus 1 times 9x squared plus 3x plus 1. All right. Number 5. So number 5, suppose you had 125x cubed plus 216y cubed. So 125x cubed plus 216y cubed. All right. What's a GCF? GCF is 1. GCF is 1. And not 5 because 5 doesn't go into 216 evenly. So it's not divisible by 5. But GCF is 1. So let's see if this is a sum of 2. What do you want to check? Sum of 2 squares or sum of 2 cubes? Cubes, because the x and y both being raised to the third power. So this is going to be the sum of 2 cubes if I can fill in these parentheses. Can I fill in the first parentheses? Yeah. What goes inside that? 5x, because 5x times 5x times 5x is 125x cubed. Can I fill in the second parentheses? Yes. What times itself 3 times is 216? 6. Well, I mean, it's 6y, but 6 times 6 times 6 is 216. Okay. So 6y though, right? All right, 6y. Now, remember if you what you could have done if you didn't think about it that way, what you could have done is taken the cube root of 216. So remember how to do that in your calculator. So on your calculator, you have remember the square root button is right above the square. You can't see it right here, but right above the x squared right here is the square root button. To get to it though, remember we press the second function and then this. The cube root, there is no, you don't see a cube root function, but you see this. You see on this notation right here. It's right above that one right here. Y'all see it on your calculator? You got to take your calculator out to look at it. It's right above this. Okay? So your index here is represented by the letter x. So I want to find the cube root. So I want to see what's the cube root of 216. So to figure that out, I got to put the index first, which is 3. So you type in 3, just like this. Then to get that cube root, you're going to say second, and then you're going to press this function right here. You see, it looks like this. See it? And then I want to take the cube root of 216, so you type in 216, and then you press equal, and you get 6. And if you were to multiply 6 by itself 3 times, 6 times 6 times 6, you should get, I messed up. So 6 times 6 times 6, you should get 216. Okay? All right. Now you know your f. F is 5x, and then L is 6y. So now you know your binomial. What's your binomial? So 5x plus 6y times your trinomial. What's 5x times 5x? 25 what? X squared. Minus or plus? Minus. And then f times L. What's 5x times 6y? 30xy. And then plus L times itself. 36y squared. So that's your answer. All right, number 6. Let's suppose at number 6, I had this. I had 64y minus y to the 4th. 64y minus y to the fourth. Okay, that's 64y. What's your GCF?
For Y.
Y. GCF is y. So I can factor out the y, right? So I get y times what? 64 minus y what? Y to the third power? Is that y cubed? Is that the answer? No, because you can look at that 64y cubed and then notice that this is going to be the difference of two cubes. And so if I fill in those parentheses, what times itself 3 times is 64? 4. What times itself 3 times is y cubed? Y. So there's my F and there's my L. And so when I factor 64 minus y cubed, I get a binomial times a trinomial. What's the binomial? 4 minus y. Good. That's a y. 4 minus y. What's the trinomial? What's going to be that first term I'm going to write? 16, because 4 squared, 4 times 4 is 16. Plus or minus? Plus the product. And what's the product of F and L? 4y. Good. And then plus the last times itself, y squared. All right, but don't forget, in your answer, you got to put your GCF. And what's the GCF? Y. So it'll be y times this binomial times this trinomial. Okay? All right, 2 more, and then I'll give you a worksheet to work on. Okay, 7. Suppose in 7 I had 8x cubed minus 27y cubed. 8x cubed minus 27y cubed. What's the GCF? 1. So, and you have 2 terms, and there's a subtraction sign between them. Is this the difference of 2 squares? No. For one thing, 8 and 27 are not perfect squares, and then x and y are both being raised to the third power. So you want to check and see if this is the difference of 2 cubes. So if it is, if I can fill in these parentheses, so here's your work. This is work you do. What goes inside the parentheses? The 2 what? 2x. What about the second parentheses? 3y. So F is 2x and L is 3y. So now you know your binomial. What's your binomial? 2x minus 3y. And now your trinomial. What? 4x what? Squared. Now remember, you got 4x squared by saying F times itself. So 2x times 2x is 4x squared. Now, is the middle sign going to be plus or minus? Plus. And then F times L. So what's F times L? 6xy, good. And then plus L squared, 9y squared. All right. And so that's your answer. Okay, one more, number 8. All right, let's suppose number 8 I had this. 1029 yx cubed plus 24 y to the fourth. So 1029 yx cubed plus 24 y to the fourth. Is the GCF 1? No, GCF is not 1. What do you think it is? Y? Okay, so you said y, right? Now here's the problem. Listen carefully. Suppose you said y. I'm going to factor out the y, just the y, because that's what some of you said. I'm going to take out the y, and you're going to get 1029x cubed plus 24y cubed, right? Okay, so then you would ask yourself, all right, is what I have inside the parentheses the sum of 2 cubes? Well, first of all, is 24 a perfect cube? Is there a number? Is there a whole number times itself that's 24? No. So then you got to go back and you got to ask yourself, well, maybe I messed up with the GCF. Maybe the GCF is not just y. So then you ask yourself, all right. So let's look at 24. What are the factors of 24 besides 1? There's 2. The fact 2 goes into 24, right? But does 2 go into 1029? No. The next factor that goes into 24 is 3. Does 3 go into 129? Yes. And remember, all you got to do is just take 1029, divide by 3, and see if that's a whole number. And it is. And then that would be 3 times 8, right? And so the GCF of those two terms is not y, but what? 3y. So the GCF is 3y. So then you factor out the 3y, and you get 343 x cubed. Is that right?
Yeah.
Because 3 times 343. Remember, that's how we get 343 right here, right? 343 x cubed plus, and then what does this become though? 8 what? Y cubed. Good. Because 3y times 8y cubed is 24y to the 4th. Y'all see that? Okay. So remember distributive property. 3 times 343 is 1029. Y times x cubed is yx cubed. 3 times 8 is 24. Y times y cubed is y to the 4th. But you can't say that's your answer and then expect to get full credit, because it's not. Because if you notice 343 x cubed plus 8y cubed, you want to check and see if that's going to be the sum of two cubes. So it is, if I can fill in these parentheses. Now the second parenthesis is easy. Let's talk about the second parentheses. What times itself 3 times is 8y cubed? 2y. All right. Now let's talk about 343. Take the cube root of that if you need to, just like we did the cube root of 216. So is the cube root of 343 a whole number? Yeah, use your calculator. Second, I'm sorry, I forgot to put the 3. So 3, second, and then that x function, 343, press equal, and you got 7? All right, do you all get 7 if you have a calculator?
Yes.
All right. All right, but what goes inside the first parentheses, though? It's not just 7, it's 7x. So I found my f and I found my L. So my answer is going to be 3y, the GCF, times a binomial times a what? Trinomial. So don't forget your GCF. What is that binomial? That's an easy one. 7x plus 2y. Now let's talk about the trinomial. F squared. F is 7x. What's 7x times 7x? 49x squared. Minus or plus? Minus. Good. F times L. 14xy. Plus L times itself. 4y squared. And there's your answer. Okay, that's all you do. All right. Okay, so